So in today's video, we are going to see sorting. Okay. As far as sorting is concerned, there are two types of sortings are there. One is internal sorting, another one is external sorting. So what is the difference between internal and external means? Internal sorting and external sorting means internal sorting which takes place within the main memory itself, whereas external sorting at the time of sorting the data, instead of using main memory, it also use the secondary storage, because in the external sorting we are handling bulk amount of data. Okay, so whenever we are facing the insufficient main memory, we go for secondary storage also. So that is the major difference between internal sorting and external sorting. So from this video onwards, we are going to see several internal sorting methods. So the first internal sorting method, it is bubble sort. Okay, so in the bubble sort, suppose we are taking this as example and algorithm is also given. Finally, we are going to see the time complexity also. So in each and every sorting method, time complexity is most important. Okay, and in the first iteration, manually I am telling first, then we go for a algorithm. So what we do means we are taking the numbers and in the array, and we used to compare the adjacent numbers. Okay, 14 and 33 is compared. So if 14 is lesser number, 33 it is a greater number, already it is in order. We are going to arrange the numbers in ascending order. So as per the ascending order, 14 is lesser number, 33 is a greater number. So that's why already it is in order. So what we do next step means we go for second number, and we are taking second and third. We have to do the just we have to compare it. So as far as the 33 and 27 is concerned, 27 is lesser number, 33 is greater number. So that's why swap takes place. So that's why 14, 27, 33. Okay. After that, 33 and 35 is compared. 33 and 35 is compared. 33 is a lesser number, 35 is a greater number. So that's why it comes as it is. Then 35 and 10 is compared. Okay, 35 and 10 is compared. So 35 is a greater number, 10 is a lesser number. So that's why we want to swap. So this swap here also swap takes place. So 10 comes here, 35 comes here. Okay, so one iteration is over. In the second iteration, I am doing the same thing. 14 and 27 is compared, no issue. 27, 33 is compared, no issue. 33 and 10 is compared. So we have to do another swap here. 10 and 33. So that's why 14, 27, 10, 33. Then 33 and 35 is compared. Already it is in order. So second iteration is over. Okay. Now we come to the third iteration. 14 and 27 is compared. 27 and 10 is compared. So it is swapped. Okay. So 14, 10, 27. Again 27, 33 is compared. So 33. 33 is 35 is compared. 35. Is the point clear? Then once again we compare with fourth iteration. 14 and 10 is compared. So we want to swap one another. So 10, 14. Then 14, 27 is compared. 27. 27, 33 is compared. It is in order. So that's why 33. 33 and 35 is compared. 35. So now we are arranging all the numbers. So how can we find it up? Swapping it takes place. So that's why once again we are comparing 10, 14, 14, 27, 27, 33, 33, 35. So once again 10, 14, 27, 33, 35 comes. So through this way, the bubble sort method, it works. Why it is called bubble sort? Bubble sort in a water, suppose the bubble which is created in the under the water, it comes as into the surface. Okay, so whenever bubble creates, wherever it creates, automatically it comes to the surface of the water. So that's why like a bubble, the lighter number it comes front, and the greater number, it is weightage number, it goes depth. So this is the meaning of bubble sort method. Okay. So now we come to the algorithm. So in this algorithm, in this procedure, we are using bubble sort with list. List is nothing but array of items. And initially we are taking loop variable. It is nothing but list count. So whatever the list is there, suppose we are taking this list count is 1 2 3 4 5. So loop equal to 5, list count. Then for I equal to 0 to loop minus 1 time. Then we are using two for loops here. The first for loop is I and the inner for loop is j. Why we are using two for loops means, and as far as the comparison is concerned, this j for loop, it is doing the comparison and swapping, whereas the I for loop, it is for number of iterations. Whenever swapping it takes place, it comes again to the another iteration. So how many iteration it takes place? 1 2 3 4 5. 1 2 3 4 5. 5 times we have to, what is that, do for this case. So in the outer for loop, I loop, it means that it is a how many iterations we are going to do, and the inner for loop, it is actual comparison of both the numbers, one another numbers. So I becomes 0 now. I becomes 0. Suppose you imagine that is 0, 1, 2, 3, 4. Usually the array starts from 0 to n numbers. So that's why, what is that? We are using loop minus 1. So I starts from 0. So that's why until third value we are doing. So automatically within the j, it is compared with the next number. So that's why 0 to loop minus 1, it is 0 to 3, and we are introducing one more variable, it is called swapped. What is the nature of this variable? I will tell you later. Okay. Now I come to the for the inner for loop, j becomes 0. Okay, j becomes 0 to n minus 1, that is loop minus 1, it is nothing but 3. So this is also 0 to 3, this is also 0 to 3. And inside we are checking j equal to 0. 0 means it takes 0th value. And if list of j greater than list of j plus 1. Suppose I am taking this list of j means, what is it? List of j, it is nothing but 14, and list of 1 is list of j plus 1. List of j plus 1, it is 0 plus 1, 1 is 33 if it is greater value. If the greater value it is in the previous one, we have to swap. So whenever this condition is 33, condition here it is false, because 14 is a lesser number. So it is checking that whether it is greater. So that's why it is false. So it comes out, j becomes 1 now. So j equal to 1. So 1 means we go for list of 1. List of 1 is 33. 33 is greater than 27. Now condition true. Okay. If condition is true, then we comes inside, swap two numbers. What we do? 27 comes here, 33 goes here. Okay. So this is what we are doing. Whenever it is swapped, swap becomes true. Then j becomes 2 now. So we are taking list of 2. List of 2 is 33. List of 3 is 35. So 33 is greater than 35. Condition fails here. So that's why no swapping takes place. J becomes 3 now. What is that? 35, 10. So 35 is greater than 10. Condition, what is that? True here. So condition is true, swapping. Swapping means 10 comes here, 35 comes here. Okay. So we comes out of this for loop because inner for loop is over. 0 to 3 is a, what is that? Condition. So 3, j becomes 3. So that's why this for loop it terminates, it comes here, and it is checking that any swapping takes place. If not swapped means break. If it is swapped means once again we comes here, once again we go to I. So now I becomes 1, then once again j becomes 0. So we are taking this result, and once again we have to compare the second iteration. So in the second iteration also we are doing the same thing. We are taking, once again we are taking 0 and 1, 14 and 27, comparing. So whatever we done in the previous case, we are doing in the second iteration, third iteration, fourth iteration, like this. Okay. So this is what the, what is it? Bubble sort method. we are doing by algorithm. Okay. So one more important information I want to tell you, that is called time complexity. So what do you mean by time complexity? In all sorting cases, time complexity is very important. So as far as the time complexity is concerned, there are three cases are there. One is best case, another one is average case, and the third one is worst case. What do you mean by best case? Best case, it is nothing but, suppose some numbers are there, already the numbers are in sorted order. For example, 10, 20, 30, 40, 50 is there. Okay. So this is the order. So in this order, what we do? We check 10 with 20 already ordered. So 20 is greater than 30? No, it is in order. 30 is greater than 40? No. 40 is greater than 50? No. So that's why within a single iteration we stop the process. So that's why the time complexity of best case, it is big O of n. N is nothing but only n times we are comparing. What is it? 1, 2, first comparison, second comparison, third one, fourth one. So within a n number of times we are winding up the process. That's why it is called a best case. What about average case? Instead of this number, so this is, we call it as best case. Average case, it is nothing but, instead of arrange, what is it? Some numbers are swapped. So 40 comes here, 20, 30, 50 like this. So this is, we call it as average case. In this is also average case. In average case, how much time it takes? It takes big O of n square time. Why it is n square time? So we are going for number of iterations. Here we are going for one iteration is n, another iteration is n square, n plus 2n, 3n, 4n, 5n, like way it goes n square times. So that's why it is called as a average case, and the time complexity is big O of n square. In the worst case also, the time complexity of bubble sort, it is big O of n square. What do you mean by worst case? What is the difference between average case and worst case? Means in the average case, some numbers are swapped. In the worst case, totally it is in reverse order. How it is there? In the worst case, 50, 40, 30, 20, 10. So like this the numbers are there. So we have to, what is it? Reverse the order. So that's why at each and every iteration swapping takes place. 50 is greater than 40? Yes. So that's why we have to swap. So after swapping, what happens? 50 comes here, 40 comes here. Then 50 compared with 30? Yes, swap. 50 compared with 20? Yes, swap. 50 compared with 10? Yes, swap. Okay. So finally what happens? 50 comes here, 40, 30, 20, 10 comes like this. Okay. So once again 40, 30, yes, we swap. So that's why in the worst case, the time complexity is order of n square. So this is what the time complexity as far as the bubble sort is concerned. I hope you understand the logic.